Hello everyone, welcome to my channel. The present topic Structure of Atom, Class 9, Module 3. Please subscribe and comment. Let us discuss about electronic configurations in this chapter. The distribution of electrons in different orbits and energy levels around the nucleus following certain rules is referred to as electronic configuration. As it is stated in Bohr's model, each circular orbit has a definite number of electrons. That means each orbit can accommodate a fixed number of electrons, and beyond that electron doesn't go into such orbit. Now let us see certain rules. Rules for filling electrons. Rules for filling electrons. The first one is any orbit can accommodate a maximum of 2n square electrons. Any orbit can accommodate a maximum of 2n square electrons. Thus, n equal to 2 or n equal to 2, how many electrons? 2n square. 2 into n is 2 square, it is 8. So second orbit, second shell can accommodate 8 electrons. n equal to 1, 2 into 1 square, that is 2 electrons. First shell can accommodate only 2 electrons. If you take third shell or third orbit, third energy level, so this is 2 into 3 square. 2 into 3 square is 9. So third shell can accommodate a maximum of 18 electrons. n equal to 4. 2 into 4 square equal to 2 into 16 equal to 32 electrons. Fourth shell, fourth orbit or fourth energy level can accommodate a maximum of 32 electrons. Now another rule, outermost shell or valence shell. Outermost shell or valence shell can accommodate a maximum of 8 electrons. Maximum of 8 electrons. Outermost shell can accommodate only 8 electrons irrespective of the 2n square rule. If fourth shell is the outermost shell, though it can accommodate 32 electrons as per 2n square, it can accommodate only 8 electrons. So these are the two rules. Now let us see the electronic configurations of certain elements. Hydrogen H11. Hydrogen symbol H, atomic number 1, mass number 1. So atomic number Z equal to 1, mass number A equal to 1. So what does it indicate? Atomic number 1 means number of electrons 1, number of protons 1. Now mass number A is 1. Now how do we calculate the number of neutrons? Number of neutrons equal to mass number minus atomic number. Mass number minus atomic number. Mass number A minus Z equal to 1 minus 1 equal to 0. So hydrogen is an element without having any neutron. Hydrogen is referred as neutron-less atom. Now, electronic configuration of hydrogen 1,1. This is, it has only one electron. This one electron enters into K shell. So electronic configuration of hydrogen is 1 in K shell. Right. Now let us see helium. Helium helium 2 4. Atomic number of helium is 2, therefore number of electrons is 2, number of protons is 2. Now mass number A equal to 4, number of neutrons A minus Z, so 4 minus 2 equal to 2. So electronic configuration of helium 2 4, 2 electrons in K shell, because K shell can accommodate, K shell means first shell can accommodate a maximum of 2 electrons. So with 2 electrons this K shell is completed. So electronic configuration of helium is 2. Now let us draw electron picture also. So in the nucleus of helium, 2 protons are there, 2 neutrons are there. Around the nucleus there is only one shell. This shell has, what is the shell? K shell. This K shell has 2 electrons in this manner. Okay, now let us see the next element, lithium, symbol Li 37. So atomic number Z is 3, electrons, number of electrons is 3, number of protons is 3, mass number is 7, this is A equal to 7, number of neutrons is A minus Z, 7 minus 3 equal to 4. Now let us draw the electron picture, and of course let us write electronic configuration. So the nucleus of lithium atom has 3 protons, 4 neutrons. Okay, first shell, K shell can accommodate only 2 electrons. It cannot take more than 2 electrons as per 2n square rule. And how many out of 3 electrons? 2 are accommodated, 1 is left. This electron enters into next energy level, that is L. So here one more electron. Therefore EC of lithium 37 is 2, 1. This is K shell, this is L shell. In this way, let us learn writing the electronic configurations of certain elements. The next element is beryllium. Beryllium Be49. So atomic number Z equal to 4, number of electrons is 4, number of protons equal to 4. Now mass number A is 9, number of neutrons equal to 9 minus 4 equal to 5. Now electron picture for beryllium, number of protons 4, number of neutrons 5. Now first shell K, only 2 electrons. Second shell, how many electrons are accommodated in second shell? Yes, 8 electrons, a maximum of 8 electrons. So here is 1. How many? Out of 4 electrons, 2 are accommodated and still 2 are left. Therefore, the electronic configuration of beryllium is 2, 2. 2 electrons in K shell, 2 electrons in L shell. Okay. Now, the next element is boron. Next element is boron B511. Atomic number Z equal to 5. Number of electrons 5. Number of protons 5. Mass number, what is the mass number? Mass number A is 11. How do you find the number of neutrons? Mass number minus atomic number. Therefore, number of neutrons equal to number of neutrons equal to A minus Z, 11 minus 5 equal to 6. Now, electron picture for boron, number of protons 5, number of neutrons 6. So, first shell, as usual, it can accommodate only 2 electrons, a maximum of 2 electrons, right? Now, second shell, what is the name of the second shell? L shell. So, how many electrons are left? See, number of electrons 5, out of 5, 2 are accommodated here and still 3 are left. These 3 electrons are in this manner. So, in the shell, electrons you can keep anywhere. But only you have to keep this point in mind. Instead of keeping all the electrons at the same position, just you scatter, which looks nice. So this is the electronic configuration of boron. So electronic configuration of boron 511 is 2 electrons in K shell, 3 electrons in L shell. Got it? Right. Now you practice the remaining elements, electronic configurations for remaining elements. Now, let us take fluorine. Remaining elements you practice, and of course I shall take fluorine. Fluorine F9, 19. What is the atomic number? 9. Mass number? 19. So, atomic number Z equal to 9. Number of electrons 9. Number of protons also 9. Mass number A equal to 19. Number of neutrons equal to A minus Z. 19 minus 9 equal to 10. Right. Now electron picture. So nucleus of fluorine atom. How many protons are there? Number of protons 9. How many neutrons are there? Number of neutrons 10. So first shell K, only 2 electrons. Second shell L, how many electrons can be accommodated? Second shell, number of electrons, maximum number of electrons equal to 2n square rule, 2 into n value second, so 2 square, this is 2 into 4 equal to 8 electrons. So second shell can accommodate a maximum of 8 electrons. But how many electrons are there? 9. Out of 9, already 2 are there. Still how many electrons are left? 9 minus 2, 7 electrons. 7 means less than 8. So these 7 electrons enter into second shell. 1 here, 1 here, 1, 1, 1, 2, 3, 4, 5, 6, 7. So electronic configuration of fluorine 9, 19. So 9, 19, 2 electrons in K shell, 7 electrons in L shell. So 2, 7. Right. Now let us see neon, Ne, 10, 20. So atomic number Z is 10, number of electrons 10, number of protons 10, mass number A equal to 10, 20, sorry, mass number A is 20, number of neutrons equal to A minus Z. What is A? A is 20, Z is 10, so it is 10. Now, electron picture. So, nucleus of neon, protons, number of protons 10, number of neutrons 10. As usual, what is the first shell? First shell can accommodate, K shell is the first shell, only 2 electrons will be there. Out of 10 electrons, 2 are here, 10 minus 2 is 8, 8 electrons can be accommodated in the second shell, and of course that is the maximum number of electrons also. Second shell can accommodate a maximum of 8 electrons. So this is L shell. So 1 here, 2, 1, 2, 3, 4, 5, 6, 7, 8. So 8 electrons. Now electronic configuration of neon 1020 is 2 electrons in K shell, 8 electrons in L shell. Okay. Magnesium, what is the symbol? Mg, atomic number 12, mass number 24. So, atomic number Z is 12. What does it indicate? Number of electrons is 12. Number of protons is also 12. Mass number A is 24. So, number of neutrons A minus Z, 24 minus 12 equal to 12 neutrons. Now let us draw the electron picture. Magnesium. What is the number of protons? Number of protons 12. Number of neutrons also 12. First shell 1, 1. So this is K shell. First shell can accommodate a maximum of only 2 electrons. Now, second shell. What is the second shell? L shell. Right. How many electrons can be accommodated as per 2n square rule? 2n square equal to 2 into second shell. 2 is 8 electrons. Right. So, second shell 8 can accommodate 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Right. Now, 2 plus 8, 10 electrons are accommodated. But what is the number of electrons? Total number of electrons in magnesium is 12. So here, 12 minus 10 accommodated already. So still 2 electrons are left. So these 2 electrons enter into the third shell. So this is third shell. What is the name of the third shell? KL. Yeah. How many electrons? 1, 2. Right. Now let us write the electronic configuration. So electronic configuration of magnesium 1224 is 2 electrons in K shell, 8 electrons in L shell, and last 2 electrons in M shell. So electronic configuration of magnesium is 282. Got it? Okay. Now let us see one more example. Argon. What is the symbol for argon? Yeah. Atomic number 18, mass number 40. So, what is the atomic number? Atomic number Z is 18, mass number A is 40. So, number of electrons 18, number of protons 18, number of neutrons, how much? A minus Z, 40 minus 18, 22. Now, electron picture for argon. Electron picture of argon. Right. Now, argon nucleus, how many protons are there? Protons 18, neutrons 22. How many electrons are there? 18. So first shell, what is the number of electrons in first shell? What is 2n square? Always you have to remember 2n square rule. So n equal to 1, 2n square. N equal to 1, 2 into 1 square equal to 2. So first shell can accommodate only 2 electrons. Okay. Now second shell. First shell is K, second shell is L. Second shell can accommodate 8 electrons. 1 here, 2 here, 3 here, 4 here. 4 pairs. So 4 pairs means 4 into 2, 8 electrons. So you can accommodate in this way also. Or 8 electrons you can scatter individually also. So now 2 plus 8, 10 electrons accommodated. but total number of electrons is 18. 18 minus 10, still 8 electrons are there. So these 8 electrons enter into third shell. What is the third shell? M shell. 1, 2, 3, 4. 4 to 8. Right. Now, electronic configuration of argon 1840. First shell 2, second shell 8, and third shell 8. So this is 288. So electronic configuration of argon is 288. Now let us see one more example. Potassium. Potassium K 1939. Atomic number Z is 19, which indicates number of electrons is 19, number of protons is 19. Right. Now, mass number A equal to 39. So, number of neutrons equal to A minus Z. 39 minus 19 is 20. Now, electron picture. Electron picture for potassium. Nucleus of potassium. Number of protons 19. Number of neutrons 20. So first shell K is 2 electrons. Second shell L is 8 electrons. 8 electrons, 4 to 8. Right. So 2 plus 8. 2 plus 8, 10. But totally how many electrons are there? 19. 19 minus 10 is still 9 electrons are there. So this 9 electrons. Now see, n equal to 3. Maximum number of electrons is given by 2n square. That is 2 into 3 square equal to 18 electrons. So, M shell can accommodate a maximum of 18 electrons. But there is another rule. What is that rule? Being the outermost shell, any outermost shell can accommodate only 8 electrons irrespective of the 2n square rule. So, here 2 electrons, another 2, another 2, another 2. So, this is outermost shell. As it is outermost shell, it cannot accommodate more than 8 electrons. Now, how many electrons accommodated totally now? Totally 2 plus 8 plus 8, 18 electrons. Still, one more electron is left. This electron doesn't enter into this shell. So, this last electron enters into next shell, next orbit or next energy level. So, in this way, this is K, L, M, and this is last electron. Now, what is the configuration? Electronic configuration you can write as 2 electrons in K shell, 8 electrons in L shell, 8 electrons in M shell, and 1 electron KL, M, and of course this is M. So 2881. Now, you have understood the electronic configurations how to write. Now, you try for calcium Ca 2040. So, for the examination point of view, you have to learn writing the electronic configurations for 20 elements. We conclude this module here, and in the next module, let us discuss about isotopes, isobars, and electronic configurations of ions. Thank you.